awesome math students! In this lesson, we will be adding and subtracting like fractions. To begin, let's make sure that we have the correct terminology when it comes to fractions. A fraction represents parts of a whole and is defined by two numbers, one on the top of the fraction bar and one on the bottom. The bottom number is called the denominator, and it represents how many pieces a whole is split up into. The top number is called the numerator, and this tells us how many pieces of that whole we are working with. For example, if we had a pizza and it was cut into 8 slices, then 8 slices represents the whole pizza. So the number 8 would be the denominator. Thankfully, recognizing like fractions is easy as pie or pizza. Like fractions are fractions with common denominators. That's it. We're working with wholes that are split into the same number of pieces. So let's say that we had 2 people that were pretty hungry and they're eating pizza. The first person eats 1 piece. That's 1 piece, which is part of the pizza, but remember, the whole is made up of 8 pieces. So we would say that that person has eaten 1/8 of the pizza. Next person, a little hungrier, eats 2 pieces. 2 pieces of the whole, and there's 8 pieces in the whole pizza. We would say that person has eaten 2/8 of the pizza. Then, if we were solving a problem like, how much pizza did both people eat all together? We would add our fractions because we are joining those pieces to find the total. And we would add 1 piece plus 2 pieces and say that all together they have eaten 3 pieces of the same whole, which is 8. Let's do a listen and watch, and then we will move into solving a couple math problems together and writing it down. I have a question. With like fractions, what do we add or subtract? How does this work? It makes me think of order of operations, which is commonly memorized as PEMDAS. And when we follow the order of operations, we know that we are multiplying and dividing first. We also understand that a fraction is a division problem. So, are we multiplying our numerators and denominators? Here's why that would not work. Let's take a problem like 1/2 plus 1/2. We know that if we have a half and we are adding another half, that's going to add up to a whole. If we were to multiply, 1 times 1 equals 1, and 2 times 2 is 4. 1/4? We know that that's wrong. So, when we add or subtract, all we need are these denominators to be the same, or we call them common denominators. As long as the denominator is a common denominator, then it doesn't matter what the numerators are. We're going to add the numerators. So 1/2 plus 1/2 is 1 piece plus 1 piece, 2. We have 2 pieces that make up the whole. 2 seconds. 2 divided by 2 equals 1. And we have 1 whole. Now let's return to that pizza problem. If we have 1 person eating 1 piece of pizza, and we have 8 pieces that make up a whole, we say 1/8 of the pizza has been eaten. If another person is a little hungrier and eats 2 pieces of pizza, and there's 8 pieces that make the whole, we're going to add to join together those pieces. All together, 1 plus 2 equals 3. 3 pieces out of the whole 8, and we would say 3/8 of the pizza. So How does it work with subtraction? Same way. What if we had a question like, how many more pieces did the second person eat than the first? We would write down how many pieces that second person ate, 2 out of the 8 pieces that make the whole, and find the difference between the first person who ate 1 piece of pizza out of those 8 slices. Because we have common denominators, we're subtracting just the numerators. 2 take away 1 equals 1 out of the 8 pieces of the whole, and so our answer would be 1/8. We're ready for a you try it. So go ahead and solve the addition and the subtraction problem. Pause the video, and when you're ready, press play and we'll compare answers. Remember, when you're adding and subtracting with like fractions, it doesn't matter what the numerator is, as long as the denominators are the same. 5 plus 4 are the numerators that you're adding. It might even help to write your fraction like this, to remind yourself that you're only adding the numerators. Our answer is 9/10. Same with subtraction. We're subtracting only the numerators. 11 take away 4 equals 7. Same denominator, 12. Answer, 7/12. So what do we do when the add-ins are both negative? Same steps. As long as the denominators are common denominators, it doesn't matter what the numerator is. Let's look at a few problems together, and I want you to write down everything that I do. The first problem, we have a -3 as a numerator, and we're adding a -1. Our denominator will remain as 5. 5 pieces give us a whole. Now, we have already practiced adding with negatives, and when we have same signs, we're going to keep moving in a negative direction. So altogether, we have -4. Let's write our denominator, and our answer is -4/5. Let's look at the next problem. We're only going to add our numerators. We have a -2, and we're adding more negative. Our denominator stays the same as 5. If we are adding more negative, that means that we are moving in a negative direction, and we have a total of -4. That's our numerator, and our denominator stays the same as 5. Our answer is -4/5. Now look at this last problem with me. -1/4 plus 1/4. Do you recognize anything special about these fractions? You're right, they're opposites. And we learned in the last chapter that opposites always have a sum of 0. But we can write this out so that we can, make sure that we understand. We are adding our numerators. We have a -1 plus 1. Our denominator is 4. -1 plus 1, we have an answer of 0. And we wouldn't write 0/4 commonly as a fraction. Instead, we would just write 0. Remember, a fraction is a division problem. And what is 0 divided by 4? 0. So this leads to our next question. How do we add numerators that have different signs? Exactly the same way we did last chapter with whole numbers. Subtract the absolute values. Greater absolute value wins the sign. I would like you to copy everything that I do. Remember, it doesn't matter what the numerators are as long as the denominators are the same. We are going to find the absolute value of -3, and we're going to subtract it from the absolute value of 1. 3 take away 1 equals 2. -3 has the greater absolute value. So our answer is -2, and we have the same denominator, 7. -2/7. Let's try this again. -5/8 plus 4/8. We are going to subtract the absolute values of -5 and 4. That is 5 take away 4 equals 1. We subtracted the absolute values of those numbers. Negative 5 has the greater absolute value, and it wins the sign. So our answer is negative 1. That's the numerator. We write negative 1, and 8 is our denominator. Negative 1/8. Next problem. Negative 11 twelfths plus 9 twelfths. We're going to subtract the absolute values of 11 and 9. The difference is 2. Now, a negative 11 has the greater absolute value. That means it wins the sign. Negative 2 is our numerator, and our denominator is 12. Our answer is negative 2 twelfths. This page has the pencil, so I want you to copy everything I do. Remember, we know what additive inverse is, and we know how to use it to help us solve problems. Additive inverse means an opposite sign change. So let's use that strategy for a couple problems. This first one, negative 5/9 minus negative 2/9, we can start by writing negative 5/9. But let's use additive inverse, an opposite sign change. Instead of subtracting a positive 2/9, we're going to add a negative 2/9. Remember, it doesn't matter what the numerators are as long as the denominators are the same or common denominator. So what we're doing is taking negative 5 and we're adding negative 2. Our denominator stays the same as 9. Negative 5 plus negative 2 equals negative 7. Our answer is negative 7/9. Additive inverse can also help in the next problem. We have negative 11 twelfths minus negative 5 twelfths. Notice that right here we have subtract a negative. We can use additive inverse to change those signs. Begin by writing negative 11 twelfths. Instead of subtracting a negative, do an opposite sign change. We're going to add a positive. Now we're going to use now we're going to use absolute value to help us solve this problem. We're going to subtract the absolute values of our numerators. 11 take away 5 is a difference of 6. Negative 11 has the greater absolute value, so it wins the sign. Our numerator is negative 6. Negative 6 twelfths. Now let's review the commutative property and the associative property. Commutative has a root word, commute, and commute means move around. In math, when we add or multiply, we can move the numbers around in any order and get the same answer. So we can use the commutative property with a pizza problem. Let's say that we had one person eat 3/5 of a pizza, the second person 1/5 of the pizza, and the last person 2/5. And the question is something like, how much pizza was eaten altogether? We might have a reason to move these numbers around to make it a little easier to add. I'm thinking if we put 3/5 right next to 2/5, I know that 3 plus 2 is 5. So we have an answer of 5/5 or 1 whole pizza. Now, we still have this other person who has eaten 1 piece of pizza out of 5, so that's our 1/5. We now add that, and we have a fraction that is greater than 1. It's 6/5. We can also simplify and say we have eaten 1 whole pizza plus 1/5. The associative property. I like to think that I associate with my friends, and that usually means that we're hanging out in groups. The associative property in math means that we are regrouping our numbers. And we can do this with addition. So if we think of pizza again, and we've eaten 1/4 plus 2/4 plus 3/4, we can put those numbers into any groups that makes it easier for us to answer the question, how much pizza was eaten all together? I kind of like the idea of grouping 1/4 plus 2/4. So I've put those in a group using parentheses. I like it because when I add the numerators, 1 plus 2, it equals 3. And then my other fraction that I have to have also has a numerator of 3. So 3/4 plus 3/4 means that we ate 6 pieces out of each whole having 4 pieces. So that means that we ate 1 whole pizza plus 2 pieces out of 4 pieces being our whole. 1 2/4. All right, now it's your turn to try it. Go ahead and solve these 5 problems. Remember to use some strategies to make it easier for you. Show your work. You might want to pause now and then play again so that we can compare answers. Let's check answers. So 5/7 plus 6/7 plus 1/7 could really be handy if we use the commutative property, because we could change the order and put the 5 and the 1 together, which add up to 6. So now we have 6/7 plus 6/7 gives us a total of 12/7. 3/8 plus a negative 7/8. In this case, we can subtract the absolute values of 7 and 3, which gives us a difference of 4. Negative 7 has the greater absolute value, so the negative sign wins. Our numerator is negative 4. Our answer is negative 4/8. In the next problem, we're adding 2 negatives, so it's negative 1 plus negative 5. That gives us a total of negative 6. Our answer is negative 6/9. With this problem, we could use the additive inverse, opposite sign change. We copy negative 5/9, but we change the signs. We're going to add a negative. Now notice that you're adding 2 negatives. The numerators are negative 5 plus negative 2. That gives us a total of negative 7. Our answer is negative 7/9. And our last problem, 1/4 subtract a negative 1/4. We can use the additive inverse and do an opposite sign change. 1/4 plus a positive 1/4, and we have an answer of 2/4. Here's our math humor for today. Who invented arithmetic? Henry VIII, of course. Ha ha ha.